Hello everyone, you are learning physics from Uncle Irodov, and in this module we will be solving Irodov's 1.9. You can see the statement of this problem here. There is a boat that can move in water with a velocity that is 2 times less than the river flow velocity. He is asking us to find out the angle to the stream direction at which the boat must move to minimize drifting. How do we know that in this case drifting will happen? We know that because the velocity of boat is less than the velocity of river flow. You will see that if v is the river flow velocity, then according to him, velocity of boat in still water is only v by 2. That means even if the boat was to travel upstream directly, the boat will not be able to overcome the current, and the current will surely push the boat downstream. So there will be drifting. But then there is a certain angle at which the boat can travel to minimize the amount of drift that it suffers. So in this problem, the strategy is to find out drift as a function of theta. And once we find out drift as a function of this angle theta, we will try to find out d of drift by d of theta equated to 0. This is a standard thing to do in higher level physics. So we start by assuming the speed of river flow to be v, and then the speed of the boat becomes v by eta, and in this case eta is 2. And let the boat travel at an angle theta as shown in this figure. So here is the figure. It shows you that this angle theta, of course, because flow direction is this is how the river flows. This is how the velocity of boat is in the river. So the angle between these two will become the angle theta. Then we try to write the velocity of boat with respect to still water. In terms of theta, it would become v by eta, because this will be v by eta. So v by eta cos theta I cap, v by eta sin theta j cap. The velocity of water with respect to ground is v I cap. So the total velocity of boat with respect to ground is velocity of boat with respect to water plus velocity of water with respect to ground. And clubbing the I cap terms together and j cap terms together, we end up with this expression. Now this j cap term shows us the velocity at which the boat is crossing the river. So with the help of this, we can find out the time taken to cross. Time taken to cross would be the total width by this velocity. And in that time, the boat would have moved a certain amount of distance downstream. So that would be the drift. So the drift will be this time, that is here, multiplied by the velocity with which the boat moves downstream. So that is this. So this is the total expression for drift after we open up the bracket and separate the two terms. For the drift to be minimum, d drift by d theta should be 0. So here we have, if you look at this expression, we have got 1 by tan theta, or we have got tan theta raised to the power minus 1. So you have got minus 1 tan theta raised to the power minus 2 here into d by d theta of tan theta, that is secant square theta. Then you have eta w into, this again is, if you notice, this again here is 1 by sine theta, that is sine theta raised to the power minus 1. So this is minus 1 sine theta raised to the power minus 2 d by d theta of sine theta, that is cos theta. Then we can solve this equation getting cos theta as minus 1 by eta, and so this would be the answer. Now here, because eta has been given as 2, we have to find out theta such that the cos of theta is equal to minus 1 by 2, and then we know that the angle is 120 degrees. This is a very straightforward step. So which means the river flows downstream and the boat should travel at an angle of 120 degrees with the river flow to minimize the amount of drift that it suffers. I hope you learned something in this video, and I hope you will keep watching other modules of mine in which I will be solving more of Irodov. See you.